So today we need to we are left yesterday with at arrays. Okay, let us go ahead with arrays and then functions and so on. So looking at this arrays, I have two vectors. One is one vector consists a length of 3 items, which is 5, 9, 3, and whereas another vector which comes with a 10, 11 till 15. So the result is array of vector 1 comma vector 2. Dimension, I have provided the dimension. Before I talk about these arrays, I just want to discuss about the matrices. Okay. Before I talk about the arrays, I just want to discuss about the matrices. Let us take a look at this one. I have implemented a vector of a sequence from 3 to 14 and I want 4 rows. Okay, the representation of the 4 rows using n row attribute. Okay, by row is equal to true will make you the arrangement of all the elements sequentially by row. Okay, so let me just show you how do I use to print the matrix. So this is the matrix. Okay, the sequential numbers from 3 comma 4 comma 5 comma 6 comma something like this was ordered in a row format. Okay, and then you can check out here. And you can check this one clearly. The n matrix of C comma C of 3 is to 14. N row is equal to 4 by row is equal to false. Print of n. Same way, but distribution of the elements will happen in a column format. Look, 3, 4, 5, 6, something like this. Now let us work on something. I just wanted to name the rows and columns what I'm showing here. Okay, so row names equal to a vector with all the row names, column names equal to a vector with all the column names. So I am going to prepare a matrix, okay, by introducing a vector of numbers. Nth row is equal to 4, by row is equal to true, dimensional names of list of row names comma column names. So take a look at this. Can you see now? The names of the columns and the rows have been changed. Now let us try to access the individual elements within the matrix. You can see P of 1 comma 3. 1 comma 3 represents first row, third column. Is this 5? Let us see. Okay, 4 comma 2. Can you please tell me what is 4 comma 2? Fourth row, second column, 13. What is 2 comma? 2 comma represents only the second row, right? Next one, what is comma 3? Only the third column, right? Only the third column. Let me show you. I have two matrices now at different vectors. I have passed as a vector of numbers. Matrix 1 and matrix 2. Let me print these matrices. Now I'm trying to add up the result. Addition, subtraction. Let me do it. Addition of the matrices. You can do it. Subtraction of the matrices can be done. Okay. Multiplication of the matrices. Okay. Division of the matrices. Okay. All of you are with me? And did you understand the matrices programs and the functions that how we have worked with? Let me just switch to the arrays. We have a couple of vectors here, and we pass the multiple vectors to an array, and the dimension refers to the C of 3, 3, 2. And let us see how it is going to show us. See, this has given us two different matrices. Each one is of 3 by 3 matrix. 3 by 3 matrix, first dimension, second dimension, third dimension. Okay, 3 by 3 matrix. You are having a two 3 by 3 matrices. In the same way, even in arrays, you can have multiple vectors giving the column names and the matrix names all together, mixing up in a one particular array and printing the results, which is of same like what we have done with the matrix. Understand this part? Now also one more thing, what we need to do, we need to try accessing these elements of the arrays. Arrays and the elements. So we have a two vectors of different lengths. We have two vectors of different lengths. Two vectors are here. Now I just want to print the result for 3. Can you please tell me what happens to this one? Third row, entire third row of the second matrix, right? Look, third row of the second matrix. First row, third column, value of first matrix, 13. Okay. This is how that we can access an array elements. You can see the second matrix. If you want to print the entire second matrix, we can use this part. Manipulating the array elements. Let's see, I do have the two more vectors representing here. Let me just print an array. What I have tried here, I have two different elements over here, and now I just want to show you that matrix 1 represents where I just wanted to make the addition of these two matrices, which is going to show you something like this, the result. Okay, you can see the printed result. Here I do have the one more vector, vector 1 and vector 2. Take these vectors and inputting as an array, and how the new array would look like. Okay, And take a look at this one. Use apply to calculate the sum of rows across all the matrices. Now the entire thing would be summed up together in order to make a final element of a sum of all the values inside. Okay, all of you understand this part? Do you have any questions? Please let me know. How it is 56? See, 5, 10, 13, 28, 28, 28. Two matrices, right? Okay, 28, 28, 56. In the same way, even rest of all the values. Okay. Any other questions? If there are no questions, then I will go switch to the functions program in the R. All of you? No questions? Okay, then let me switch to the functions then. So you can see this built-in functions. We have some built-in functions in order to use, and also we can make our own user-defined functions also. But still, let me show you a couple of built-in functions. Okay, making a sequence of the numbers from 32 to 44. Okay, and also mean of the all the numbers from 25 to 82 by using the sequence of numbers using the column. Okay, you can make the sum of all the numbers, something like this. These are all the internal existing pre-existing functions. User defined function, I'm going to create my own function. New dot function equal to function of a. This a is an element or a variable for which we need to pass a value. Okay, remember that one. Once we enter into this function, you have something called a for loop. For loop is implemented for I in 1 till the past argument value. Okay, and I'm just making square, so I'm trying to print the squares of all the numbers in a sequence. So I'm passing this 6. Now let us see what happens. It is giving the squares of the numbers from 1 to 6. Sorry, are you good here? Are you all good? Okay, so now I can call a function without an argument also. By passing all the necessary stuff inside, I can call a function without an argument like this. Which function definition? No, 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 no. It is not that. No, it will not be. It will not be created. But function name could be created. Okay. Okay. So I have one more function where I'm passing the 3 arguments together all together. Okay, but I'm making one mathematical combination. So you can see that mathematical combination 5 into 3, 15 plus 11, which is 26. Okay. I can also call the same function by making these kind of arguments in a reverse order. Okay, so here you can see I have given the values of a function variables directly right away over there itself, and I'm calling them. This is how it is. And the new function which is representing 9 comma 5, which is going to be something like this. Okay, and here I do have one more another function, something like this. You can see that I haven't passed the two arguments. Instead, I have just passed only one argument here. Okay, but still it has evaluated the inside the function without giving out an error, but it has given an error once after the execution of the whatever it is possible for it. Did you understand? This kind of flexibility is there with the R programming. Okay, all of you, are you all good? So this is all about the functions. Now let me just go ahead with the conditional statements. Apart from conditional statements, we have data frames, data reshaping, factors, operators, web scraping. So operators needs to be discussed before I'm going to talk about the conditional statements. Okay, I'm sorry. So what I will do, I will cover this web scraping tomorrow. Okay, we will have the session tomorrow also. Okay, the time will be mentioned by Teja or any of the other admins through email. Okay, we will have the change of the schedule tomorrow for tomorrow, which is a Saturday, right? Tomorrow is Saturday, right? So tomorrow I will discuss about the web scraping and even some visualizations tomorrow. So today we are let us try completing this rest of the other things if we can do. Hmm? See, operators, very simple. I have a couple of values in a vector. X refers to the 2 comma 5.5 comma 6 and y refers to the 8 comma 3 comma 4. So I can do many mathematical operations like plus, minus, means addition, subtraction, division, remainder, okay, and whole, power square, and also relational operators, which will give you the Boolean values. Okay, let me just show you how do we do this. You can see many of the things. When it is x greater than y, it will check whether it is true or false along with these numbers. Okay, and also you can see the logical operators v and t. See, v represents 3 and 4. Okay, you make 3 and 4, 1 and 1, whatever it is going to show you true. True and false should become false. Why? Because and is here. Okay, in the same way, either or will work in something this way. True. Whenever is there something 1 0 or 1 false, here any one should be true. Here both are false. 0 represents false, right? So ultimately this is going to be false. Okay, so not equal to. Double and. Double and will make you ultimately true. Based upon the evaluation of the entire values. Even this or also double or will make the evaluation, which is going to give you only one particular resultant as a value. Assignment operators. See, this is generally we will call it as a left assignment. These are all the different types of left assignment operators. Okay, we can always make a representation of all these things and we can print them. Okay, if you can take a look at this one, all these things has been showed in an imaginary values or a complex values. Okay, right assignment, colon operator, 2 till 8, it is going to print you 2 till 8. T, 1 till 10, V1 in T. So you can always try to define, okay, whether it is there or not. Yes, if it is there, it will show true. If it is not there, it will show you false. Okay, so the matrix, you can always print a matrix. I already told you, I will show you some transpose of the matrix. This is the transpose of the matrix. Okay, T of M. Okay, so the 2 by 3 matrix has been converted into a 3 by 2 matrix. Okay, so you can also print the matrix multiplication, and also you can make something like this, which is also same. There's nothing much difference. Print v2 nt false, something like this. Okay, any questions here, operators? Okay, fine, let me switch to the conditional statements. X is, here I have taken some x variable, okay, where is 30 long, and if is of integer of x, you can see that x is an integer, but is truth. If truth in x, truth is found and truth is not found should be shown. Can anyone tell me why it is showing truth is not found even though that I have given as truth? All of you, please tell me why this is not considering. I have what is truth. There are 3 values inside. Yes, it is case sensitive. Okay, so I have a small letter t and here I am representing a capital letter. So it is a case sensitive stuff. And also, even when you execute this one, truth is found the second time. Why it is not found first time? Because I have used the capital T. Okay, I can also use a switch method, or I can say like a switch case. Okay, which takes the case which case that I'm going to use, and I can have all the different conditions or the values associated with that. Okay, whatever the selected values would be shown over here. Hmm? Okay. Okay, so this is all about the conditional statements. Okay, now we have the data frames into the picture. Are you all good to go ahead with this data frames? Hmm? Are you good me to continue with this data frames and data reshaping? Data reshaping I will cover it tomorrow. Okay, before web scraping I will cover the data reshaping. Okay, so for today what I will do, I will do it for data frames and factors. Then we will close the session for today. Okay, tomorrow we will do the data reshaping and web scraping and many other things, and also database connection also. We will make a database connection and we will retrieve the data. Okay, so okay, now coming to the data frames. See, emp.data data.frame, we will use a function called a data frame, which is a data.frame. Okay, when we are using this one, we should have some sort of prerequisites before we start this part. Okay, what is all? What is that actually? Column names should not be empty. Okay, column names should not be empty, and the row name should be unique. Okay, and the data stored in the data frame can be of a numeric, a factor, or a character type. Each column should contain same number of data items. Okay, this is all the prerequisites before you use the data frames. So let me show you. I have an employee ID, I have an employee name, salary, start date, everything is given, and I just want to print out the same thing. Okay, let me just go ahead. This is my data. Okay, now I just wanted to know the structure of this data. Okay, this is my structure of the data. What is the structure? Employee ID is of integer type, employee name is of a character type, salary is a number type, start date is a date type. Okay, it is all about the structure of the data. str, summary of the data. Okay, minimum how much, median, what is the median, what is the mean? Okay, if it is a categorical data, what is the class of the category? It's a character. What is the length? 5. Start date, median date, everything. Okay, create the data frame, and I just want to see only the specific columns like employee name, salary. See, employee.data is the one which is holding our data frame, which is a rows and columns format. And I just want to list out only the employee name and the salary. You can see the employee name and the salary. Okay. Now, I just want to print the employee data of only the first two rows. What I have given? One column 2, one column 2. And what else that I want to do? I want to make third and fifth row with the second and fourth column. See how I have represented. This is how that I can execute. Look, third and fifth row with the second and third column. I just wanted to expand the data frame. I'm going to add one more column actually. Okay, which is called a department. Okay, so employee.data $department, and I have given the all set of values in a vector, and I'm going to print this out, print the same. So see, the department is in a last column. Okay. All of you understand this? So finally, I just wanted to bind the two data frames. Okay, employee.data, employee.new data. Okay, together we can make a binding of the two different data frames, which is showing you up. Okay, along with the department. Understand? This is what all about the data frames. Okay. All of you. Are you all good with this? Shall I go ahead with factors? Let me go ahead with factors. Yeah, we'll share you all these programs, whatever that I'm going to explain you tomorrow and day after tomorrow also. Okay, I will share you all these programs today itself. Okay. Now let us take a look at this one, a vector which is having the east, west, east, north, north, something a random data. I just want to print this data. This is how it looks like actually. I just want to factor. I just want to check whether this is the factored data. What do you mean by factored data? Means, uh, you know, it is showing something false. Okay. If you wanted to print that factored data, you need to use a function called a factor, and finally it will show you, means it will filter you the unique values of the all duplicated data. Okay. Understand all of you? So now let us check whether it is a factor data or not. Yes, it is true. It is a factor data. Hmm? This is a factor data. Now let us jump on to this. Height, weight, and gender. Hmm? And I'm going to input this one into a data frame. This is how it looks like. And I just want to print male and female is a factor data or not. Yes, it is a factor data. And I just want to see, and I have done this, I have printed the gender column to see the levels. I have seen these levels, male and female, once after I do the factoring. Okay, right or wrong? So now I just wanted to change the order of levels, especially by giving them externally. Okay, factor underscore data comma levels east, west, north. Okay, and this is how it looks like, east, west, north. And also here we have something called a GL. GL is a function where it will take up three different attributes or arguments inside this n, k labels. N represents an integer value which will give you the number of levels. K represents an integer value which will give you the number of replications. How many number of replications that you want, it will replicate your data into that many number of replications. Okay, so I just wanted to replicate the Tampa, Seattle, and Boston. See. Okay, where we can implement this one, when we have a column, okay, which is having almost nearly 1000 rows or 10,000 rows or a million rows, okay, where you are not sure like whether how factored, how many levels the factor the data is, it is and all, you can use this factor data. Okay, using the factors you can easily identify that part. Okay, all of you understand? So this is what it for today. Do you have any questions in the today session? We will meet again tomorrow. See you all. Bye.